Hello everyone. In this presentation we are going to discuss about power flow studies. As the power flow solution is a solution of a network under steady state condition during normal operation subjected to certain inequality constraints under which the system operates. As you see, the power system is a very complex thing. So in this one, active power, reactive power is involved. As a power system is a connection between number of nodes, number of substations, number of terminals, number of loads, number of generators. So it is a very big system. So when so many things are connected together to operate under a stability condition is a complex task. So there are many constraints. So these constraints can be in form of nodal voltages, reactive power generation of the generators, the tap settings of the tap changing under load transformers, etc. So as there are certain loads changes are there in the system, there are generator added, there are generator deleted from the system, then there are so many faults in power system. So the power flow study is one of the very important concept in the power system. As we see, the power system will have contingencies. So these contingencies, when we study under this power flow analysis, we can see that it happens because of sudden change in voltage or sudden change in reactive power at a particular load. So how this thing can be avoided can be studied in power flow studies. When we are studying these things, there are some assumptions. The system is assumed to be operating under balanced condition and is represented by single phase network. So a three-phase system can be made as a equivalent three single phase networks, and to start with we can consider a balanced system. So there are some necessary conditions. So these studies gives nodal voltages and phase angles, hence the power injections at all buses and power flow through lines. These are all essential for design a new power system and for planning extension of existing system for increased load demand. The power flow solution also gives the initial condition of the system for analysis such as transient stability and contingency analysis. Here the contingency analysis means when there is either increase in the load or under some faulty condition, or when there is a huge load flow from a particular buses. So this type of contingency may happen because a particular line or a particular bus active or reactive power flow is increased than the specified limit. So due to this type of conditions, a contingency may happen. This contingency sometimes may lead to blackout, brownouts. And the transient stability is one of the very important topic in the power system. Transient stability, which will decide whether the system under such condition can be stable or not. When there is a sudden change in load, there is when sudden change in the generation, how the whether generator is able to sustain that load or not. So whether the transmission system is able to sustain the flow of power is decided with this transient stability. Means when there is sudden change in the load, the generator should accelerate and see that the generator gives required power. Similarly, when there is a sudden decrease in the load, the generator should see that it try to reduce the inputs required and should stabilize the system. So there is a control from generation. Similarly, in transmission we should see how we can compensate these transients, how far it can take. So these things are important when we are studying the power flows. So in the power flow solution there are some important steps. So the formulation of the mathematical description of the problem. So it is very important as the power system involves hundreds of buses. So manually calculating is a challenging task. So that is why we make this a computer program, so that it is very easy to calculate through a computer program. So when we want to make this into a computer program, so it is required to express all the things into the mathematical formula. So to start with, we should take one bus frame, and we should define a reference bus. Similarly, we should try to calculate in a easier way, so that we can save memory of the computer and the time which will take to solve this problem. So in this thing, we use admittance matrix. So admittance matrix, when we are doing calculation, so it is easy to use admittance matrix, as we can add these admittances in our mathematical formulations, mathematical calculations. The network equation in the nodal admittance form results in a complex linear simultaneous algebraic equation in terms of node currents. So we need to come out with new methods through which we can solve these complex linear simultaneous algebraic equations. In power system, powers are known rather than the currents. So active power, you can say reactive power, complex power, total power. These are all more important factors than what we calculate in terms of current. So these results in the equation known as the power flow equations, and these are all non-linear and will have complex solutions. So main steps in power flow solution: application of suitable numerical technique for solution. Nonlinear power flow equations must be solved by iterative techniques. So these are all, as we can see in power flow, we have many methods like Gauss method, Gauss-Seidel method, then Newton-Raphson method. We have artificial neural network method. We can use fuzzy logic method, genetic algorithm method, or any other nonlinear power flow. Means a algorithm which can solve nonlinear equation using iterative technique can be used in this one. Thank you.